Hi, my name is Syed Waqas Zamir. I will present CycleISP framework, which is a data synthesis approach for image denoising. Deep neural networks are making unprecedented progress in image processing and computer vision. The major driving force behind the success of neural networks is the availability of large-scale datasets. However, for image denoising, capturing a large-scale dataset is extremely difficult and non-trivial. As a result, image denoising is mostly studied in synthetic settings, where white Gaussian noise is added to clean images to generate their noisy versions. While neural networks produce impressive results on these synthetic datasets, they generalize poorly when applied to real camera images, as reported in recent studies. In both of these studies, BM3D performs the best, which is a 13 years old method and does not use learning. The reason is that the real camera noise is fundamentally different from additive white Gaussian noise. At the camera sensor, we have signal-dependent photon noise. The effect of noise in raw sensor data is well understood, and therefore it is relatively easier to estimate a decent noise model with just a few parameters. Sensor noise, when passes through different stages of the camera imaging pipeline, it becomes very complicated. Noise in RGB image is spatially and chromatically correlated. It is signal dependent and not necessarily Gaussian. It implies that for synthesizing noise in RGB images, we require more sophisticated noise models than widely used additive white Gaussian noise model. Furthermore, these noise models should take into account the influence of camera imaging pipeline. We present CycleISP framework that models camera imaging pipeline in forward and reverse directions. It allows us to synthesize realistic noise data in sRGB and raw spaces as following. Given a clean RGB image, we first convert it to clean raw image using a subnetwork. This subnetwork learns to invert each step of the camera imaging pipeline and thereby converting input RGB images to raw measurements. Next, we add sensor noise to this clean raw image in order to generate noisy raw image, which is finally transformed to noisy RGB image using another subnetwork, which learns the regular camera imaging pipeline. This way, from any RGB image, we can synthesize clean and noisy image pairs in RGB and raw spaces. This realistic data can then be used to train any image denoising network. In our paper, we also propose a new image denoising algorithm. The architectural details of our denoising method and CycleISP framework for data synthesis can be found in the paper. We perform experiments on two real image datasets. The first one is Darmstadt noise dataset and the second one is smartphone image denoising datasets. Both of these datasets provide images in raw and sRGB domains. Therefore, we have two tracks for image denoising, one for raw denoising and the other for sRGB denoising. Here are the results of raw denoising on D&D benchmark, where our method performs better than other competing approaches. The trend is similar on SIDD benchmark. For the sRGB denoising track, our method produces better results than those of other methods. Same is the case for SIDD dataset. Now I will show some visual results. In this example, it can be seen that our method is effective in removing real noise, whereas the competing algorithms RIDNet and CBDNet are not able to completely remove noise and their reproductions have splotchy textures. In this example, we show that our method recovers the structural content better than other approaches. Here's another example. And in this final example, compare the recovery of the text. We have released the code and pre-trained models if you would like to use them. Thank you.